In this video, we're going to look at evaluating expressions using the Pythagorean identities. So first, we're just going to recall some geometry. So remember, if we have a right triangle, then we can use the Pythagorean theorem, which says a squared plus b squared equals c squared, where c is the hypotenuse. So remember, when I'm working in the unit circle here, this is the point xy, which means the horizontal value down here would be x. My vertical value here would be y. Also remember, if this is the angle of rotation, if this is my central angle, then x is my cosine value of theta and y is my sine value of theta. So if we think about the Pythagorean theorem would say x squared plus y squared equals my hypotenuse, which is 1, so 1 squared. So changing this using the trigonometric values, instead of x, we're going to use cosine theta, and instead of y, we're going to use sine theta. So we're going to have cosine squared of theta plus sine squared of theta equals 1 squared, which is 1. Notice the squared is before the theta, which is typically how it's written. If you have the squared after the theta, such as cosine theta squared, that implies that you're squaring the angle measure before taking the cosine. So we would have to add parentheses in here like this. So instead of doing that, we just use the simpler notation where the squared is before the theta. So just keep that in mind. So this is my basic Pythagorean identity. Sine squared plus cosine squared equals 1, or cosine squared plus sine squared equals 1. From the Pythagorean identity, we can also get two corollary statements from that. So I'm going to start with this same statement, cosine squared theta plus sine squared theta equals 1. I'm going to divide each of these terms by cosine squared of theta. So if I'm dividing both sides of the equation by this, then we're just changing the form of the equation. We're not changing the equation itself. And then I'm just going to use my basic identities here to simplify. So cosine squared theta over cosine squared theta is just 1, plus sine squared theta over cosine squared theta is going to be tangent squared theta, equals, and then 1 over cosine squared theta is going to be the same as secant squared theta. So now this is one of my corollary statements to the Pythagorean identity. So then we're going to go back to the original Pythagorean identity, where we've got cosine squared theta plus sine squared theta equals 1, and this time we're going to divide everything by sine squared theta. And again, if we simplify here, we have cosine squared theta over sine squared theta, which is going to give us cotangent squared theta, plus sine squared theta over sine squared theta is going to give us 1, equals 1 over sine squared theta, which is going to give us cosecant squared of theta. So another corollary statement from the Pythagorean identity. Also up here with my Pythagorean identity, we can just manipulate this equation and get cosine squared by itself, which would give us cosine squared theta equals 1 minus sine squared theta. So just moving the sine squared over to the other side. Or if we start with the original statement and we just get sine squared by itself, so sine squared theta is going to be 1 minus cosine squared theta. So all of these statements really come from this one statement of cosine squared plus sine squared equals 1. So we're going to look at how we can use some of these formulas to evaluate some specific sine, cosine, tangent, secant, etc. expressions. Okay, so in this example, we need to find sine and tangent. We're given the cosine value, and we know that the tangent value is less than 0. So using these two pieces of information, we're going to determine what quadrant we're working in. So remember, in my quadrants, the first quadrant, the x and y coordinates are both positive. In the second quadrant, it's negative, positive. In the third quadrant, it's negative, negative. And in the fourth quadrant, it's positive, negative. So use the information they gave you. Our cosine value is 3/4. So our cosine value, which is your x coordinate, is positive. And then my tangent value is less than 0. So my tangent, which is y over x, is negative. So my x coordinate's positive, and then my y coordinate has to be negative for me to get a negative answer here with y divided by a positive x value. So I know that my y value is also negative. So what quadrant has an x coordinate that's positive and a y coordinate that is negative? That's quadrant 4 here. So I'm going to draw my triangle in quadrant 4. Put my theta at the origin, and then we've got from here 2 different methods that we can use to solve this. So the first method is going to be similar to what we did in chapter 4. So I'm going to use like the SOHCAHTOA stuff. So I know that my cosine value of theta is 3 over 4. And I know that cosine is adjacent over hypotenuse. So I'm going to fill that into my triangle. So my adjacent side is 3 and my hypotenuse is 4. Then what I'm looking to find is to find my y value here. So I'm going to use the Pythagorean theorem to do that. So I'm going to go y squared plus 3 squared equals 4 squared. So I end up with y equals plus or minus the square root of 7. Then I'm going to come back and look. I'm in quadrant 4. I found a y coordinate, which I know has to be negative. So my y value is negative radical 7. So that's why it's always important to decide what quadrant you're in. Now that I have that, I can answer my ratio questions. So I want to know the sine of theta. So sine, remember, is opposite over hypotenuse. So that's going to be the negative radical 7 over the hypotenuse, which is 4. I also was asked to find my tangent value, so tangent is opposite over adjacent, so negative radical 7 over 3. If instead we want to use a newer method here, we're going to use the Pythagorean identity statements that we just talked about. So here I want to use a Pythagorean identity statement that contains my given value, and my given value was cosine. So from my Pythagorean identities, I know I can use the general Pythagorean identity, which says cosine squared plus sine squared of theta equals 1. And then I'm going to plug in my cosine value that I know. So I'm going to plug in the 3/4. So this is 3/4, remember, squared, because it's cosine squared, plus sine squared of theta equals 1. Now I'm just going to do some algebra to solve. So we end up with the sine of theta is plus or minus radical 7 over 4. And then again, I go back and I look at my quadrant. Here I'm finding the sine value, which is the y coordinate, and I know it has to be negative. So I know my sine of theta is negative radical 7 over 4. Then I still have to find my tangent value. So in order to do that, I'm going to use just my basic identities. So remember, tangent of theta is equal to sine of theta over cosine of theta. And so we just found the sine value is negative radical 7 over 4, and the cosine value was given, which was 3 over 4. And so that's going to reduce to negative radical 7 over 3. So the exact same answers we got before. All right, so here's another example. We want to find secant and cotangent, given that cosecant of theta is 5/2, and this time we are between pi over 2 and pi. So again, first thing, regardless of method, I would think about is what quadrant am I in? And this one says we're between pi over 2 and pi, so I know that I'm somewhere in here in quadrant 2. So I'm going to, again, put a dot in quadrant 2 anywhere. Draw my segment to the origin and the x-axis, put my theta value in, and then we've got 2 methods. So here, because we started with a cosecant value, we're going to use our basic identity reciprocals. So we have cosecant of theta is 5 over 2. So that tells me that the sine of theta is 2 over 5. And I know sine is opposite over hypotenuse. So again, I'm going to fill that in. So 2 and 5. And then I'm looking for this x value here. So again, I'm going to use the Pythagorean theorem. So x squared plus 2 squared equals 5 squared. So we get x equals plus or minus the square root of 21. Again, looking at my quadrant, I'm finding an x coordinate in quadrant 2, so I know I want the negative value. So we're going to say x is negative radical 21. Square root 21 cannot be simplified, so we can just leave it like that. And now we're going to go ahead and find our values. So we need to find secant. So in order to find secant, I would want to know cosine. So my cosine value is going to be negative radical 21 over 5. So that means my secant value is going to be negative 5 over square root 21. I also need my cotangent value, which means I need to take the reciprocal of tangent. So tangent is going to be opposite over adjacent, so 2 over negative square root 21, which means cotangent would be negative square root 21 over 2. So if we want to use our Pythagorean identities, again, I'm going to look at the value that I have, which is cosecant. So if I come back and look at my formulas, I'm going to look at the one that has cosecant in it, and it's this one. So this is the formula that I'm going to use. So cotangent squared theta plus 1 equals cosecant squared. Remember, I have my cosecant value, so I'm going to plug that in and square it. So cotangent squared of theta plus 1 equals 5/2 squared. So this is going to give me cotangent squared plus 1 equals 25 over 4. So I should end up with cotangent of theta is equal to plus or minus the square root of 21 over 2. So again, go back and look at your quadrant. I'm in quadrant 2, which means my tangent value is going to be negative, which means my cotangent value is going to be negative. So now I know cotangent theta is negative radical 21 over 2. We were also asked to find the secant value. So coming back to my equations, I need to find secant, and it's in this equation here. And so if I know my tangent value, I can use this equation. So since I have my cotangent value, I know my tangent value. So I have my cotangent value, which means my tangent value is the reciprocal of that, so negative 2 over radical 21. And then we're going to use that second equation. So tangent squared of theta plus 1 equals secant squared of theta. So plug in my tangent value, which is negative 2 over radical 21 squared plus 1 equals secant squared. So here I'm going to get 25 over 21 equals secant squared of theta. So secant of theta is plus or minus the square root of 25 is 5 over the square root of 21, which we don't know, it's irrational. So we get plus or minus the square, or plus or minus 5 over square root 21. Again, secant is the reciprocal of cosine, so in that quadrant, my cosine value is negative, so my secant value is also going to be negative. So then we're going to choose that negative value.